on online communities and user interfaces for crisis response. And her work shows an amazing ability to do theory-building research that's embedded in real, live, ongoing events of global importance. And so please welcome Kate.
Thank you. So I'm hoping my slides will show up perfect. That's not my thing. All right, so I'm Kate Starbird. I'm going to my second year as a professor at the University of Washington. I'm going to talk about crisis, crowds, and online convergence. And I'd like to note that a lot of this research I completed when I was at University of Colorado with my colleagues there, including Leisha Palin. So this picture was taken sometime last year, late October, early November, on the East Coast in the aftermath of Hurricane Sandy. And in it, there's a woman with a phone, maybe texting, maybe tweeting, sending a photo of that car-tree interaction that's going on behind her. And in the wake of that event, there was a ton of social media activity where people were sharing information like this. And at some point, I got this call from a reporter, and this person wanted to do a feature story about Sandy being the first social disaster. And would I talk to him? And I said, sure, I'll talk to you. I'll help you out. I'm not sure you're going to be able to lead with Sandy being the first social disaster. So first off, we've been seeing social media use for disasters ever since there was social media. It's a growing trend. I'll show you that in a second. Second off, disasters are and always have been inherently social. Everything about disasters has to do with disruption of lives, of human lives. So this has been an increasing trend, the use of social media during disaster. These are a lot of events, a lot of these that University of Colorado was studying. We collected a lot of data, tons and tons and tons of data. Very interesting stuff. I'm not going to go over all of the numbers, but the main point here is during something like Hurricane Sandy nowadays, you're going to have thousands of tweets per second sent about these events. And so my research looks at this intersection of social computing and crisis events. Social computing being social media sites and other platforms that enable us to communicate, as well as the human behavior that those sites are affording or enabling. And I look at that in the context of these crisis events. And by crisis, often we've looked at natural disasters, we've looked at mass emergency events, and other kinds of disruption events, including mass protest events and things like that. And there's actually one of the things we've been seeing ever since the beginning, and this follows what we already knew about behavior in crisis, is that these crisis events are catalyzing mass convergence online, where affected people, as well as people from all over the world, are converging in these interaction spaces, and they're coming together at a massive scale, creating some of those numbers that I just showed you. And there's a lot of opportunity for this activity. So this photograph, actually, I pulled off my Twitter feed last week during the floods in Colorado that affected many of my friends who went from disaster researchers to disaster communities doing the work on the ground there. But this is a picture of someone has taken a photo of the road that leads up to one of the mountain towns called Lyons. And this picture shows you what you would now know if you live in Lyons, is you're not getting out of Lyons by road anytime soon because the one road that goes up there is gone. And this was shared by a viewer. It was picked up by a news media who reposted it. And there's all this opportunity. All these devices are ubiquitous. People are taking these pictures in every event. There's this opportunity for us to use this information. People are sharing with their neighbors. They're sharing it with the remote crowd. They can share it with responders. We've got all this information about what's going on during crisis events that could help us improve our situational awareness. They can help affected people and responders make better decisions. And so there's a lot of possibility there, a lot of potential. We've also got the ability, crisis responders are starting to turn to social media and other tools as another channel to get the message out, to tell people what they need to do in the moment, in real time, to be able to give evacuation notices and things like this. There's also a lot of challenges related to this digital convergence. And the first one I talked about a little bit is just the volume. There's just so much information. If you're an affected person, how can you make sense of thousands of tweets or Facebook posts or whatever per minute? It's almost impossible. Well, it isn't possible. And then within this, okay, so we have a lot of those pictures that are going to help, that give me information in real time. I can't go that way. I need to evacuate. But there's a lot of the rest of almost all of the information is going to be noise. So we've really got this really interesting signal buried underneath this huge amount of noise. It really varies across events, but something like Hurricane Sandy, less than 1% of that information was going to be really useful coming to the space for the first time through social media. Another problem with social media or information during crisis on social media is lost context. So the information loses a connection to the original person who sent it, the time it was sent, and the context of the conversation that it was in. And that leads into the next problem, is that as it propagates or spreads through the system over time, it feeds into this problem of misinformation. When we talk to emergency responders about whether or not they want to use social media as input into their decision-making process, their real big concern is misinformation, both purposeful and accidental misinformation in this space. And a final problem is this problem of unstructured data. So there's a lot of metadata associated with social media posts, but at the end of the day, what we're really interested in often is that content, and that content turns out to be unstructured and often hard to process and written in truncated languages and altered text language and things like that. So this gets me to the problem that I've been looking at ever since I started in this space a few years ago, and that is, how do we take all this information that's being shared through social media sites, somehow process it, and create resources that have filtered it and organized it, categorized it, resources that can help responders and affected people make decisions in the moment, in real time or near real time. And it turns out to be a pretty complex problem. So initially I was looking, I had a computer science background, like looking at some computational solutions and things like that, and I think there's a lot of promise for those, but right now, the things that we would turn to, like natural language processing and strategies like that, weren't necessarily designed for the short message content and the non-standard language of social media posts, and so they haven't quite caught up. But again, there's a lot of promise there, but I'm going to talk about another approach which aligns well with what Rob was talking about, and that is that the crowd is already working to organize information. So the crowd, in different ways, that remote crowd I talked about, is in different ways working to help make sense of this information in real time, to help deal with these problems of too much information. And this follows what we already knew about human behavior in disasters. So sociologists of disasters have known for a long time that after a disaster event, people will converge onto the scene of the event to, among other things, offer help. They self-deploy. They're called spontaneous volunteers often. And so what we've been seeing is just spontaneous volunteerism in the space in these social media spaces after crisis events. And I'll give you a couple quick examples here. So a lot of my work looks at Twitter for some various reasons, but one of those having to do with the fact that a lot of the information is public on Twitter, and we can search it, and it makes it a very usable thing for the people that are affected as well as people that are studying it. But so these are tweets that were sent after Hurricane Sandy. I don't know if you remember this, but in New Jersey, people had lost, they were having gas shortages, and they were trying to figure out where they could get gas. So people started turning to Twitter to post where they got gas. And they started adding these little things, these hashtags to their tweets. So the hashtag actually was a user-generated or user-driven convention added to Twitter. Twitter didn't have anything to do with hashtags in the beginning. But users said, hey, we can use these tags to mark up our tweets to make them more useful to people, to make them easily searchable, to tell people what we're talking about. And the hashtag actually, not coincidentally, also had initial uptake and traction during the 2007 San Diego wildfires. But in this case, people were tagging their tweets to let people know where they put NJ gas on the ones where they were getting gas, what the cost was, whether they were price gouging, whether there was a long line, where to enter the line. So they were sharing this information on Twitter, and they were self-organizing by putting these tags on it so others in their community could search for this information and figure out how to get gas. Someone in this space then started a Twitter account themselves to collect all of these, and that person would monitor all the information, and then someone could just ask them a question, and they would say, okay, where are you? Let me look at what I've got. Okay, you should go this way. You should talk to this person. So that somebody decided that they were going to be the curator of all this information. They created an account, and they did that. This other group for the same problem is a group that has a high school teacher and some students that were in New Jersey but not as affected, started to put all this information on a map. So they would scour the social media They would also look at official sources, and they would put, and they kept this live for several days of where a gas was available, where it was out, where they didn't know, and they would keep this information updated. And so you see these different sort of behaviors of people trying to help. And so I've been looking at this crowd work for events for about 5 years, 6 years. And I call it crowd work. It aligns with some of the things that Rob talks about in terms of crowdsourcing, and yet there's some very interesting differences. And I'm going to talk about 4 different kinds of crowd work, but the first 4 different forms, and they sort of, they're all aligned and they build off of each other. But the first is just this digital volunteerism, the people that self-deploy and try to help out in different ways. And so this was an example of just a single digital volunteer. They decided, I'm going to do it. I'm going to start helping in this way. I see this other behavior, and I'm going to help and put it all together. One of the first events where I was studying digital volunteerism was actually during the Haiti earthquake in 2010. And we were doing an intervention that had very little traction. But through it, we ended up seeing these people that were trying to help, just like we were trying to help. And they were doing all these fascinating things. And then we interviewed them and talked to them, and we studied their behavior from all their tweets during this time. And we found this group of people, and they would all start out sort of by, I went on Twitter, I didn't know what I was going to do, and I just wanted to help. And then what I started doing was I would look for all the good information that was live or something that needed to be attended to right now, and then I would retweet it. Or I would, and I would try to amplify the message. So they're like acting individually as sort of these curators, but at a larger scale, they were actually acting to amplify the message of things that were that they thought to be live information or actionable information. We also saw others who were routing information, so they would figure out which organizations or people were on the ground, and they would find information that applied to some place that these people were near, and so they would try to send information to people that were there and could respond to it with more or less effect, depending on who they were talking to. And then over time, after, they would start out for a couple of days, all they did was just randomly retweet information they thought was good. And then they figured out, oh, I need to be verifying information. So that's going to be something important. So they started to verify information. They would put confirmed on the information that was confirmed. They would put unconfirmed or not true on the other information and send it out. And we also saw them acting as remote operators. I'm going to read this tweet because some people tell me it's hard to understand. But this woman has sent out a tweet, and this other woman has retweeted it. I'm stunned. Have gotten supplies in, saved people from the rubble, brought them doctors. We have the best team. We are volunteers. And they also eventually said volunteers. But there's an interesting backstory here where Melly Mello, this woman who's in French-speaking Canada, she's a self-deployed volunteer, deployed via Twitter, ends up initially filling up cell phones for people in Haiti. Then she develops connections with them. Then she starts seeing where people have needs. And she starts sending the people she knows now through the cell phones to get supplies to bring them to people that she's meeting on social media. So she literally, for a few days before the operation settled and the UN got in there and took control, was moving supplies on the ground in Haiti in just a fascinating case. So these people, in some cases, are having impact. In some cases, it's less impact. So we've seen these digital volunteers acting in different ways. And one of the most interesting properties is that a lot of them, initially they'll start out working alone. But over time, they'll start to coordinate their work with others. They'll start to connect with other people. They'll start to work together. They'll come together as emergent response organizations, which has an online correlate. We've seen that behavior, or offline correlate. We've seen that behavior offline as well, but we're seeing it online. So this is a network graph of those volunteers. And some of them, there's actually a big bunch of people that weren't actually connecting with each other. But the rest of them, they were connecting with each other through their tweets. They were retweeting each other. They were talking to each other. They were mentioning each other. And they actually formed this pretty tight network graph where they all, not all, but a large portion of them ended up connected. And we went back and interviewed a lot of these people. And we said, you connected and you talked to all these different people in this graph. Did you know that person before the Haiti earthquake? Did you know them online or offline? And we ended up in our interviews getting that we found, of 20 people we found that replied to our interview request, 3 knew one other person in the graph. And we came about 1% of the connections had existed prior to the event. And a lot of them had just come up afterwards where they connected. And some of them developed very close relationships and had a lot of communication back and forth between them. And this is very clearly just an emergent organization online. In another very interesting effort, another group organized around the Ushahidi crowd map platform. And the Ushahidi crowd map platform, I'm going to just give you a tiny bit of where it came from. And there was an election in 2007 or 2008 in Kenya, and there was ethnic violence afterwards. And a bunch of bloggers got together, and they got together with some programmers and created a platform where people could report ethnic violence. And during the Haiti earthquake, a group of people led by Patrick Meyer at Tufts appropriated this platform and started using it to aggregate reports of people on the ground in Haiti who needed things. Whether it was they were trapped, they needed water, they needed food, and they collected all these reports, and they had people in the crowd process them. So they had they recruited help from the Haiti diaspora to translate the information from Haitian Creole to English. A lot of this information was actually coming through a system that allowed them to text. People on the ground could text directly to this information bank, and then members of the crowd were processing this information, geolocating it, and putting it onto maps. And over time, they actually developed, they started coordinating their work in interesting ways. They moved into teams. The initial students and the people that they recruited from the crowd started to coordinate in different teams. They had people in charge of reports, people in charge of verification, people in charge of geolocation. People started developing different kind of expertise. And we really saw like an online collaboration that turned into an organization. And this organization, as well as the volunteers in different ways, made a move that some of these organizations have done. Not all of them have done it very well, but at least 2 of them are still ongoing from that time. They've become ongoing virtual volunteer organizations. So a subgroup of those people that were involved in those efforts laid down the infrastructure to keep responding to event after event after event after event. And what actually happens is one of them became a 501(c), so they're a nonprofit. Other ones are just sort of networked still, but they're working for some infrastructure. But they keep responding, and what they'll do is they'll respond to the next event with almost the same people, but they'll bring in new spontaneous volunteers. So that network will go away for a while, and then an event happens. The network will come back with a core group of volunteers, and it'll bring in new people. So we see these networks sort of rehydrating with a new center of gravity and slightly different actors, but coming back now over and over again after these initial events. And we've got a bunch of different digital volunteer communities that have developed, and I won't have a lot of time to talk about them in detail, but there's some of the names of the organizations that are ongoing and responding to different crises in different reasons. And so there's another approach, another way the crowd works that is slightly different. That is slightly different, but ties into these activities of digital volunteerism. So we've got this idea that every member of the crowd works to organize the space. So I talked about it as there's a lot of noise. There's a lot of noise, people retweeting, passing things around, saying, just commenting on things. But it might be possible to use all that noise to find a signal and use this aggregate information about what we know about how digital volunteers work to use some of their activity in aggregate. Digital volunteers and just other people in this space. So one of the interesting things about social media, and we've been talking about this for a while at University of Colorado, is that so much of it is derivative, right? So a huge percentage of tweets are, especially during crisis events, are going to be retweets, or they're going to be information that points to a URL somewhere online. They're not new information coming to the space for the first time. Another large portion is conversational, mentions, and then other social media is similar. We've got likes or shares or upvotes or something. And so if you look at these individually, as you're watching, and it's interesting, if you look at it in aggregate, you can see these sort of complex recommendation mechanisms taking place. Some through user-generated or user-driven conventions like on Twitter, but others are encoded in the system structures. And there's information within this information, and I think there's a lot of actual work from the crowd being done. Even a person who just goes online for 5 minutes and retweets 2 things during the Haiti earthquake could be useful information that could help us. And so I kind of look, and this is that network graph again, and I'm going to show you a little bit about how some information, a report about human trafficking, propagated through that graph in about an hour, one day. And so what's interesting for me is to think about that network being there, embedded in a much larger network. And then you see these pulses happening. every once in a while with information in this little sub-network of volunteers. And what can we learn about sort of following it or being able to track those pulses? In some ways, this is a sensor. This is a cognitive, distributed cognition, a sensor for information, whether it's good information or possibly even bad information. And these networks, we can see these networks working this way. And one of my goals is to design ways of perceiving that and figuring out or answering questions like this one. So there's this big thing. We want to be able to detect misinformation. And Mendoza et al. Did a couple early studies on this, and they tracked the movement of false rumors after the 2010 Chile earthquake. And they found that the crowd spreads misinformation, but the crowd also attacks misinformation, which confirms some of the things that I was seeing with the verifying behavior. And they suggested we could use this aggregate crowd behavior to detect rumors. I'm going to show you a couple of rumors that showed up after the Boston marathon bombings. This was one that was asinine. They claimed that this girl was killed running the marathon. And it was totally untrue. And yes, we found some corrections. Some people did correct this information. But the signal of the misinformation is massive compared to the size of the correction. And if we want the crowd's correction to be useful, we have to find ways of amplifying that correction. So how can we amplify that correction? This is another rumor. I'm not going to spend too much time on it. It's a little bit more insidious because the crowd had actually speculated and misidentified one of the suspects. And we actually looked at different kinds of questioning behavior or correction behavior. And we think that there might be ways, this is early research, we think that there might be ways of sort of detecting these signals of the attack and therefore being able to call out misinformation. In the way that Mendoza said, although they had this idea that it was about 1-to-1, and what we're finding is it's not 1-to-1, but these signals are pretty interesting. That's an easier way to see some of the stuff that's going on and the interaction between speculation and misinformation. In this case, this rumor traveled a lot differently than some of our other ones in that the corrections actually caught the misinformation at about the same time, but not before the actual announcement went out of who the suspects really were. So the crowd had actually sort of corrected itself before it happened, which was fascinating. So this, again, if you could understand how the crowd attacks and corrects misinformation. And I want to stress, because I've done this before with using the crowd to locate people that are on the ground, tweeting from the ground of events, is that you kind of have to understand the behavior. Yeah, I could just put every metadata feature of Twitter into my machine learning classifier and see what happens, and we've had decent results. But there's sometimes features that you don't know are there until you start studying it. And I think there'd be some interesting things about looking at this at a really detailed scale and pull those out as features and start to use them for detection. I just mentioned that. All right, so we've got this idea of crowd work as all these things. And I was asked to come here and talk about a couple technical problems in my space. And I thought, okay, it's really hard because everything about what we do is in a space with crowd work and crisis these are socio-technical problems. And the domain itself is so social, and the solution, it involves people. It's incredibly social. And so it's hard to separate the two. And I think to understand that, to start thinking about what this behavior means and how we can design for it and enhance it and scale it up, we've been working to empirically understand the capacities and functions of crowd work, the motivations for participation. When you think about these organizations and these collaborations, how are they going to progress from event to event to event? And it turns out altruism gets people involved at first, but that's not why they stay around. They stay around because they're getting reputation capital, they're making new friends, they're making connections. And how do we develop systems that allow them to access those different kinds of motivations for participation so these efforts can be sustained? And again, when I'm thinking about designing for crowd work during crisis, we've got a time-critical and safety-critical context. There's very little tolerance for people letting in for automated solutions that don't perform well, right? So we can have automated solutions that are pumping out 86% accuracy, but we've got to feed that back in with different workflows. We've got to feed that back in at the next level back to people. So I think about this as sort of a layered system of filtration where we've got some automated solutions sending information to volunteers, sending information maybe back to some more classifiers, and maybe back to some higher level expert crowd that's going to make different decisions at that end. And integrating computational solutions with these human computation solutions all through the way. And one last thing I want to comment on, so I'm going to wrap it up here, but I've been in this crowdsourcing community, and I've been attending some of these things, and I've seen it all over the years. And I've always wondered what it is about my work that just doesn't fit in, and not just that it's not micro work that I'm studying and the solutions that we're thinking about, although one of the ones that I did try to intervene with was micro work, because it turned out to be easier to do that intervention. But what is it about what I do that's different? And it's this property of emergence. All of this behavior is emergent, and we're seeing the crowd sort of improvise its own solutions in the moment. So I'm caught in this position where I want to design for it. I want to help them. I want to scale this up. I want to make it work. But I don't want to take this crowd and make them do this when there's all these other creative solutions that they've been improvising and making them on their own, right? So what is it? How can we design something that allows for emergence? Twitter is fantastic for that. It's so simple. It was so baseline simple in the beginning that people appropriated it for all sorts of different things in all sorts of different ways. So what kind of tools can we design, not just ones that can package up and I can make this map and we can get everybody to geolocate one thing and then we've got it all mapped. But what else? What can we do that I can create something that allows somebody to say, I'm in a crisis, I'm going to appropriate that in this way, and I'm going to be able to do this range of things. So it's this tension between how much to prescribe and how much flexibility to allow. And messy systems are hard to design, but this has been really messy work that I've been watching, and it's been really fascinating. So just like to thank all my students and collaborators, and thank you all for your time, and Scott for inviting me. It's been a great opportunity to be able to stand up here and share my work. Thank you.
Yuan Chen from University of Pittsburgh. One general question regarding how we can not only analyze the behavior of the users during the crisis, but also can we really do something to guide or direct the response of the users on the social network?
So I left it out because it takes a long time to explain, but I know it's easy to answer in questions. So one of my first forays into this space, after we did a large empirical study of some Twitter use during floods. And then I came up with this idea. I said, we see all this information, and it could be useful. It's not. We don't have natural language or natural language processing solutions that can solve it. So what I'm going to do is ask people to format their information on Twitter in a way to call out the information we need in a systematic way that'll make it easy to process. So basically, instead of train the classifier, train the users and ask them to use Twitter in this way. It turned out to be really tough to get affected people to put formatted information where their location looked like this and it was in this place and the topic of their tweet was there. But it turned out that the crowd started taking this information and translate it for me. So what would happen is the crowd would be able to use this formatting technique, and we were able to solve it. So there's this tendency to want to intervene. But what I've learned is that affected people, so what they know about emergency response, nobody ever prepares. You can never get people to prepare. There's only a couple windows of opportunity, and that's when the disaster is either happening to them or happening to someone else, a disaster that could happen to them, that's likely to happen to them. Otherwise, people won't prepare. And so to get people to adopt a device or an application beforehand in anticipation of a crisis has been tough. I know FEMA just released one to sort of shape user behavior and guide them to report directly to them. But I would bet that there's still going to be a lot more information shared on social media with people's social networks before people go and take a device and share it directly with FEMA. So there's all of these. It's that human behavior, and this is at the level of the affected people and the people that are your citizen reporters at the ground. Is how do we shape them to put in information that we can use, whether it's through a mobile application or something else? But it's a big question, and I've tried a couple different things, and they have been less successful than I would have hoped. Yeah.
Hi, Dan Steingart from Princeton University. What kind of leadership emerges from these volunteers? These things happen instantly, and there are a lot of pretty peer-to-peer graphs, but does the crowd pick a leader? Does a leader emerge? And then what is the lifetime of that leadership?
Yeah, it's a fascinating question. I tried to say it was lateral organizing once, and someone said, nothing's purely lateral organizing, right? At some point, they're coordinating work, and somebody's telling other people what to do, even when somebody doesn't want to be telling other people what to do. So the Haiti earthquake example, that Melly Mello started, she became a leader almost instantaneously. And other people, whether they were learning from her as she was doing it, or she was directly interacting with them. We saw people, as they developed expertise, start to tell other people how to do things, and they started, just positioning themselves as a leader, whether they had expertise from other crisis response, or whether they just were there first and had learned a few lessons along the way. So yes, I do think leadership emerges, and I think that would be an interesting thing to study within these networks, is how and can we see through the patterns of interactions who those leaders are. And where they come from. And right now, a lot of the leaders are the people that are sort of going from event to event, who are bringing that expertise with them. But new leaders emerge. And you also, a year after Haiti, there were all these different groups that had tried to lay down structure to go from event to event, and they started fighting. They started fighting for attention, for territory, for who was going to do the big map next time. That's kind of gone away now, but you just get the same things that you will get with a bunch of NGOs in a very limited reaction space that doesn't have the organization of the UN and tells everybody exactly what to do. So, yeah, it's fascinating human behavior, but that's a great question to look into.
Brian Thorough, Auburn University. How involved is Twitter, Facebook, and the other companies with you? Are they just giving you data, or are you able to throw out ideas that they have like a crisis mode that they could turn on when the crisis occurs?
So one of the things I learned about Twitter early on, so we had that first idea, and the idea was based on and I wouldn't get help from Twitter, right? But someone who had worked with me early on with it decided to ask, and they came back and like, oh, well, we won't block you if you send too many tweets, right? So that's as far as they would go. They're pretty agnostic, and I think that's good and that's bad. Certainly there were things that I could have done that might have been more effective if I had had the help of Twitter. But something about that agnosticism is the same with the design. They're not playing favorites. You know what you're going to get. Okay, they were supposed to take Twitter down and do some maintenance and during the protest in Iran in 2009, and they didn't. And they announced that they kept it on because they wanted to make sure that could go. But in terms of getting too involved, they haven't been. I will say my brother went to interview for a job there, and he said, yeah, everybody knew you. And I was like, oh, I didn't know they knew me. I've interacted with a few people, and it wasn't everybody, but whoever it was that was interviewing him. So I think they're aware of the work, and I think they're interested. And I think there was something about Twitter, even when they developed it, I think somebody had in mind emergency communications when they first developed it, and part of the reason why it's so short and everything. So I think I don't necessarily need anything more. I think just having it there, being so flexible, it's been so helpful for so many people. And I'm not sure what they need to do except maybe get rid of the spam from the disaster hashtags. Just work a little harder at that. And I think they've had some interventions that they've been trying to do in Japan, where Twitter was actually being more active around things, but I don't know how that's worked out. I think people would complain. I think people want it to be agnostic. I think the public does. It's just my hunch.
Tuhin from United Technologies. So the part that you were talking about emergent behavior, what sort of bearing does it have on general engineering systems? One of the big problems in making electrical systems for aircraft, as the 787 and beyond, is that you can have formal specifications for each of the subsystems, but when you connect them all up, it doesn't behave the way you want it to, right? So does this research, have you looked at trying to do things with other kind of systems that?
I haven't. I'd be really excited to do that. I have just started to, I think we've always recognized that emergence was there, but I think I started to think about it and explore that topic a little bit more in depth. I found a colleague at the University of Washington who sort of aligned looking at online collaborations and in scientific collaborations and looking at emergence. But I think to really apply it, not just online, but apply it to these other problem spaces would be fascinating. And I'd love to talk to you more about that.
Hi, Liz Gerber from Northwestern. Great talk, Kate. When you were talking about emergence, it made me, and the challenges with designing these systems, it made me think of where could we draw inspiration from the past? So the question I pose to you is, what can the Boston Tea Party tell us about how we should design these systems? What can spontaneous soccer moms getting together and creating events tell us about this? I think we have hundreds of years of organizational theory around collective action, and I would wonder, technology was not always a part, but there was always communication. How would you think to use those as points of inspiration?
Well, I think I will go home and start looking about how to use them for inspiration. No, I think that's a really good idea. And I think there's some... The difference isn't in kind often when I see the behavior. And I compare a lot of what we've been seeing online to things that have happened offline for years. The difference is often in scale and geographic distance, right? So we can span geographic distance in different ways. And we can scale up to larger sizes. And does that have an effect of kind? Maybe it does. And that's kind of, I think that's one of the more interesting questions, is when does it get beyond what we could have done and the kinds of problems we could have addressed before we could connect in these massive ways. Some of it, the real-time processing here is one of those aspects. But what kind of problems can we solve with collective action because we can connect in these massive scales? There's a lot of other problems that are pressing that are not in the crisis space that I'd love to start exploring. And I've got some collective action books on my shelves that have not been read yet, so I'll put those on my list. And again, we can talk more about that. I'd love to talk about it.
Narayan Ramesh from the Dow Chemical Company. One of the questions I had was, first of all, it's a fascinating talk, and I like the approach that you can use information that's available to analyze and respond to things and so forth. But I was wondering if there is a way to sort of separate the sort of the malicious misinformation from the not so malicious misinformation. In some cases, it might just be an honest mistake, versus a directed sort of approach to mislead somebody. And with these kinds of tools and techniques, are there analysis schemes that can allow for discerning the different types of misinformation, if you will?
Yeah, I think with some of the more malicious ones, our signal for finding them is going to be more in how they initially spread, who they spread through, what network did that. Especially when we think about people trying to interrupt or disrupt political protests and different things. What we'll actually see go on there, I've seen a couple colleagues at the University of Washington, they showed me their data, and I said, I think that's this, they'll set up what they call as astroturf, so fake grassroots, set up a bunch of fake accounts, and use that to propagate out this bad information. And once it gets out there in a large enough scale, it looks like it's real because this group is propagating. So the ability to sort of in real time identify that this network is all sort of insulated, it's all the people, all their followers are kind of the same people, and root them out. So to do it at the network level of who their relationships are, how long that account's been around. So there's these different ways of sort of trying to use all of the interactions about who they are and what they do, as well as what people say about them, to figure out, okay, that's misinformation. And what I'd like to do is have a system where if I have Twitter giving me tweets, I'd like to say, here's your information, but here's a little flag. This one's being questioned somewhere. Somewhere somebody has questioned this. Or this one, you know what, they've got an insulated network, and they've got 12 retweets, but they're all in the same little network, and it looks like they've done some astroturfing. So I think there'd be ways to sort of surface that information that could help just slow misinformation and pull those scales down. Because one of the things that's insidious about misinformation is it spreads much further, and the correction just doesn't get to as many people. So a lot of people never understand that things have been changed. So it's an important problem. Yeah.
Hi, Janice Lee from Six From Hill. I have two general kind of questions. One is during crisis, there's some really well-established kind of crisis management organization out there, like Red Cross came across. Mm-hmm. So I think just want to hear your comments on how is it based on your study, is it encouraging during crisis instead of going to these really established organizations, is really better off to kind of start forming your own organizations to kind of help? The second question is, kind of tie back to your one of the slides have a bullet point on incentive or motivations, and just want to see like some of these very structures, established organizations, they have pay positions. I mean, not like very high benefit pay, but they have pay reasonable. Would that be an incentive or disincentive to really do the right things?
Yeah. Okay. So I think I have answers for both of these. So. 2010, the Haiti earthquake was actually sort of a marker. It was a turn in recognizing digital volunteers and social media as part of the response space. 2011, I think, the Red Cross set up their first digital operations center, and they used digital volunteers within. So they tapped into some of these volunteers. And some of the larger group that had developed around them, tapped into them and started using them within, or trying to incorporate them into their operations. The only problem is when you talk to the Red Cross, their operations and their social media team are still separate. So the people didn't actually get to have an effect on operations, but I don't think that's going to stay there for very long. One of the things about this behavior is a lot of it was out in front of what emergency response could do. Because emergency response has legal, ethical, structural issues that cause it to be sort of institutionally resistant to being able to take on these new forms of work and even take in these new information streams. Right? They didn't know how to weigh the data. They don't know if it's biased, if there's digital divide issues. They might not be able to use it. Right? So where people could be organizing it and using it in different ways, the emergency responders have been slow, but they're getting there and they're moving. And FEMA's been a big proponent of using social media, and Red Cross has been trying different ways. So I think it would be interesting to see these established organizations start to leverage this behavior and shape it into there's enough things going on. We've got some creative solutions and people coming up with their own, communities improvising their own. But you've got somebody remote, they want to help. Maybe the Red Cross can bring them in to just handle all the information that gets sent to the Red Cross. They had thousands of messages sent to them per day during the Haiti earthquake, and they didn't know what to do with them. So they've definitely got some issues. And your second question, I had an answer to it, was, remind me what the second question was.
Related to their pay institute.
Right. So we saw one of these organizations that laid down structure. They wanted to go from event to event to event. It was around the Ushahidi platform. They developed a standby task force. And they hired 2 or 3 people as paid positions. Not very much, but paid. And everyone was like, well, he got paid and I'm not getting paid. And wait a minute, that person, and why did they choose that person and not me? And then everybody quit. That was part of the whole, like, everyone gets mad at each other. And it may be that there is a big disincentive. But the only problem is there are jobs that involve keeping these organizations running over the long term that sort of have to be paid. And so there's some interesting things that have to be settled out in terms of how do they get how do they incorporate paid work with volunteer work. And it'll be interesting to see how they do it. And one way might be to go through existing response organizations.
Okay, thank you. So it's great to have Duncan Watts as our concluding speaker for this session. And Duncan's been one of the pioneers of this area that's emerging, known as computational social science, and been doing a lot of work both from the theoretical and practical side on designing and analyzing societal networks. So, Duncan.
Great. Thanks, Tanzine. I want to start out by just giving a very high-level overview of why I'm interested in this field of computational social science, and then tell you a little bit about it. I don't really need to tell anyone in this room, or really anybody actually, that over the last 20 years, the sort of revolution that we've been going through in terms of digital technology and communication platforms has revolutionized all sorts of ways of doing things. And this is true for the way we communicate, for the kinds of business models that we have these days. We have all sorts of interesting kind of social challenges in terms of intellectual property and privacy, and even how sort of ordinary everyday behavior. And as we've seen this morning, we also have lots of fantastic new tools for helping us solve everyday practical problems. The tack that I want to take now, which is sort of where we were going to, and I was excited to hear this in the question time at the last in Kate's talk, is that, as a social scientist, the way that I think about the web is less as either a thing to study in itself or a way to build new tools, but a tool for actually studying other kinds of questions that we can ask about society. So the analogy that people often give in my field is that the web is like the telescope, that it's a tool for making previously invisible things visible, and just as the telescope in doing so revolutionized the physical sciences, we hope that the web can revolutionize the social sciences. So just to sort of step back for a moment and say, well, what is it about social science that makes it social precisely? And again, this is a question that just came up a few minutes ago, that this question of emergence. So when you people who are not sociologists are often puzzled by what sociology is. And there are many answers, and they say, if you ask 5 sociologists what sociology is, you'll get 7 answers. I will try to give you one of mine, which is that really what sociologists study are what we think of as collective entities. So firms, markets, cultures, families, these are all aggregations of people. We talk about them as if they are actors, as if they do things, as if they make decisions, but we also understand that at some level they're just groups of individual people who have their own kind of aspirations. These people are interacting with each other in some sort of complicated way, and we get something that's other than just a group of people. Right? So this is what outside of sociology is typically called emergence. In sociology, we have a special name for it called the micro-macro problem. And in a way, the core scientific question of sociology is how do you get from the micro to the macro? The problem, and I think one reason why the social sciences have had trouble keeping up with the physical and natural and engineering sciences over the last 100 years, is that these are intrinsically difficult problems to study empirically. So if you just think about, how do I, understand the spread of information through a large population, maybe you need to have observational data for, millions or hundreds of millions of people, plus all of their interactions, plus everything that they're doing over a long period of time. This is a phenomenally difficult challenge to solve just in terms of observing things and describing them. And then an even more difficult challenge is if you want to intervene, if you want to try to understand cause and effect, it's extraordinarily difficult and in many cases actually impossible or unethical to run experiments at this macro scale. So the point I want to make, and next time you want to go and poo-poo your sociology colleagues for not being as smart as you are because they can't solve differential equations, just remember it's very, very hard to do science when you can't measure anything and you can't do experiments, okay? And this is the problem that we are stuck with in sociology. So in some sense, every question in sociology is a micro-macro problem, and these are all hard problems. There are no easy problems. Okay, so what's so exciting about being a computational social scientist or a sociologist or whatever it is that I call myself these days at this point in history is that some of these historical constraints are starting to lift. If you have been paying attention to the hoopla over big data recently, which is unfortunately difficult to avoid, you will be aware of the fact that all of this activity that people are performing online is generating an enormous amount of digital exhaust or digital breadcrumbs. These are some of the words that people use. But the way to think about it is that we are not just getting a lot more data about what people are doing, but we are getting lots of different types of data, and we're getting it at incredible granularity. So you're seeing individual level behavior at scale. So this is we're starting to sort of get to this level of being able to observe the behavior of lots of millions of people over time at the individual level. So this is a new thing and raises all sorts of interesting possibilities. The other thing that's going on, which is more closely related to what Rob was talking about, is that these web platforms like Amazon's Mechanical Turk are not only helping us to build interesting tools, but are also lowering the cost of being able to do traditional social scientific experiments, except now, instead of in a physical lab, we can do them in a virtual lab, and this is often much cheaper and much faster than the old way of doing things. And then we can also talk about field experiments, which is another type of experiment where you're doing randomized assignment out in a naturalistic environment. And that also is something that can be facilitated by these web platforms. So the result of these developments is a new field that some people call computational social science. This is a sort of contested term. but let's just call it that for today. It's really the emergence of this field at the intersection of the social and the computational sciences. So for the rest of the talk, I want to give a couple of types of examples, one of the sort of observational / big data type, and the other illustrating what we can do in terms of experiments. And then, if I have time, I'll try to conclude with some challenges. So the first thing I want to talk about is just to give you a flavor of what can be done with the data that we can gather online. Is this very old question that has been around for many decades in sociology and marketing and economics, which has to do with adoption processes. Why do people adopt new products, new ideas, new behaviors? Why do certain of these things succeed and spread widely and others not? And when something does succeed, what is the dynamics of that? What is the process by which it goes from being a small thing to a large and successful thing? And you can see that there's a pretty short step from that question to this related question of contagion. How do things spread from person to person? And the reason is that we're social beings, the world is complicated, and so for all sorts of reasons we pay attention to what other people are doing, we learn from each other, we coordinate with each other, sometimes we just mindlessly copy each other, or if you follow Justin Bieber, you just mindlessly retweet everything that he says. And so you can sort of see, by analogy, how this sort of seems like the way that diseases might spread from person to person. And in fact, this metaphor of the disease, the infectious disease, has been invoked for hundreds of years to account for the behavior of crowds. So this is an idea that goes back a long way in history. And more recently, we see this sort of intuitive idea formalized in terms of many different types of mathematical models, some of them inspired directly from models of infectious diseases, and others are motivated in somewhat different ways. But the point that I want to make here is that, as is the case often in social science, we have lots and lots of models and very little data. So it's very difficult to sort of disambiguate between them or try to evaluate which ones you can take seriously. Regardless, one thing that's common to all of these models is that when we think about contagion, in our mind's eye, we have a picture of something like this. So when you talk about something going viral, you kind of think about the way a disease spreads, which is to say that it starts off in one place with one person, and then it spreads to a few people, and then each of them spreads it to a few people, and each of them spreads it to a few people. And when it becomes this big object, it becomes big through a process of multi-step peer-to-peer contagion. So it's big, it's multi-step, and it's peer-to-peer. So these are the three kind of attributes that we assume or that we impute to a viral process. The problem is that historically the kind of data that we have about adoption processes looks like this. It's aggregate, it's the population level, and you just see sort of how many widgets have sold, or how many on the left-hand side, how many doses of tetracycline have been prescribed by doctors. This is a famous paper from Coleman, Katz, and Menzel in 1957. And the right-hand side is the classic paper by Bass, and he's looking at new product adoption. So this is sort of the standard type of data that we have in the management science literature. The problem with that type of data is that there's all sorts of ways to produce these sort of S-shaped adoption curves. You can get them through viral spread. There's lots of models that can reproduce those, but there's lots of models that have nothing to do with viral spread that can also reproduce those. Simple population heterogeneity can do the trick, or marketing efforts. So again, there's like just having a model that generates a curve that looks like the data that you have is not actually an explanation of that data. The other problem with historical data is that we typically only get it when something succeeds. That we don't, if no one pays attention to a new idea, the researcher doesn't know that they're supposed to go and look at why that idea didn't succeed, because it just never rises to the level of interest. So this is what social scientists call, and statisticians call, selection on the dependent variable, and it's a huge problem when we try to understand success. Let's see, can we, okay. So to disambiguate between these theoretical models, we have to be able to observe individual level data, so person-to-person diffusion, over a large population, and we have to be able to see everything that's happening, including the things that are not interesting and that we don't care about, right? This is sort of the bulk of everything, as it will turn out. And historically, this just hasn't been possible. But recently, again, because of the web, we are starting to see studies that are actually leveraging exactly that type of data. And you can see that the earliest of these studies is only back in 2005. So this is sort of a very recent development. And once we have that kind of data, we can start to ask new questions. So, and I'm going to ask these two questions today. How much adoption is actually driven by interpersonal diffusion as opposed to some other process? And what is the relationship between popularity and virality? So the first question is work that I did with Chad Goyle and Dan Goldstein when we were all at Yahoo Research. And we took 6 unrelated projects that had all been done by us or by other people at different times, all of which had some sort of social component in them. All of them were designed in some way to spread or to go viral. And I don't want to go into the details of these. There was a game, there was a corporate giving campaign, there was a social video viewing app, there was a premium IM service, there was a network survey with a social recruitment component, and then there was a large sample of web content diffusing over Twitter. So the point I really just want to make about these 6 applications is that they're all completely different, right? There's an enormous diversity here. These are different types of adoption processes spreading over very different networks. We use different inference procedures to infer the act of diffusion. In some cases, we could see it directly. In other cases, we had to infer it from our knowledge of the underlying graph. They ranged enormously in size, from a few hundred to tens of millions. So the point is not that any one of these examples is sort of an unbiased representation of a universal adoption process, but that they're all biased in very different ways. So if we see the same patterns across all of these 6 examples, we have some confidence that these patterns are robust. And in fact, we see incredibly robust patterns. So the way to interpret these these motifs, is that a single dot refers to somebody, in this case, introducing a piece of content into Twitter and nobody paying attention. Okay? So this is something that receives 0 retweets, 0 subsequent adoptions. This is where you introduce something and one of your friends adopts it. This is where 2 of your friends adopts it. Here is a case where you adopt it, one of your friends adopts it, and one of their friends, who is not your friend, adopts it, right? And so what's remarkable about this picture is a couple of things. First, that if you look at these numbers, this is the percentage of all observations that are accounted by each of these motifs. That a very, very large, a high sort of 90% of all observations are accounted for by the most 5 common motifs. All of these are very small, simple structures. These are not like the pictures that I just showed you of things going crazily viral. Nothing really is going viral here. And there is tremendous commonality. So there's 5 top positions for each of 6 examples. So that's 30 possible configurations that we might see when we go out there in the world and look. And we actually only see 7. Right? So there's almost complete agreement, even in terms of these numbers. There's very close agreement across these very, very different examples about how things spread. So this is what we call the buzzkill law of social media, that most of the time nothing happens, and that when something does happen, most of the time it's not very interesting, right? So simplifying the previous picture, going across all those 6 examples, we find that 90% of the time, on average, it doesn't spread at all. About 8% of the time, 1 person adopts it. About 1% of the time, 2 people adopt it. And everything else that you've ever heard about, Gangnam Style and Call Me Maybe and everything else, they're all in that little blue bar there, right? The vast sort of the body of the iceberg under the water is all of this stuff, right? So if you had a really, really stupid model of diffusion which said 90% of the time this happens, 8% of the time this happens, and 1% of the time this happens, you would capture 99% of all adoptions, right? So this is sort of bad news for people like me who have spent years of our lives trying to sort of come up with theoretical models of adoption, all of which predict much more interesting things than this. Okay. But you're thinking, okay, fine. I know things go viral, okay? So don't tell me that. Don't take away the pleasure that I have from knowing that this crazy video has 1.5 billion views on YouTube. It's the most viral thing that ever happened, except possibly for the Spanish flu back in 1917. So the criticism that you should have as a reasonable person of the results that I just presented to you was, okay, fine, you just looked at really crappy stuff. You didn't look at the things that go viral, right? You were just looking you were looking under the street lamp instead of over where the interesting things are happening. So that's a fair criticism, and the only way to solve it is to keep looking, right? And so we figured, well, some of these were pretty large samples, pretty large data sets, but maybe they weren't large enough. If we go back to Twitter, if we just focus on things that get at least 100 retweets, so this is pretty popular on Twitter. If you tweet something and it gets 100 retweets, you're probably pretty happy with yourself. I don't think I've ever gotten 100 retweets for anything. That only happens like 1 in 3,000 times. So if somebody introduces some content, you have to do that 3,000 times before you get 100 retweets. If you want to get 1,000 retweets, that takes 1 million attempts, okay? So if you want to sort of study 1 in a million events and you want to have a lot of them, maybe thousands of them, you sort of need on the order of 1 billion observations. This is completely absurd by historical social science standards. You just can't. It's like observing a sort of decent fraction of the global population. But actually, you can do this now using the Twitter fire hose. And so that's what we did. We took a year's worth of data from Twitter, and we took this is not exactly true, but it's almost exactly true, every single piece of video content, every news story, every image, every petition that was put on Twitter over a 12-month period. This is now about 1.4 billion tweets in total. And then we subset just on the things that get at least 100 retweets. So now we're sort of avoiding the criticism that we're looking at the lousy stuff. We're only looking at things that at least 100 people think are interesting. And that's now a much smaller subset of just 350,000. And then finally, we crawled the whole active follower graph, which is about 10 billion edges. So now we can say, OK, like we're looking at popular things. How do they get popular? And there's a couple of different theories that you might have. The first one is the one that I told you about earlier. And the second one is to say, well, not so fast. We live in a media landscape, and the Super Bowl is watched by 80 million people, but no one would say the Super Bowl is viral, right? It's just got a huge broadcast potential. And likewise, if you put something on the front page of Yahoo, 100 million people will see that. And so something can get very popular very fast, but not necessarily because it went viral. It could be just getting broadcast. So we want to be able to go and look and see, well, how do things get viral? Is it one or the other? And the answer, which is very common in social science, is that it's neither, or it's sort of both, but then it's lots of other things as well, right? That, in fact, basically whatever theory you have about how things go viral on Twitter, you're going to be right some of the time, and then there's going to be a lot of the time when you're not right, right? That almost every conceivable thing happens in terms of things becoming popular. So up in the top left-hand corner, you see a huge broadcast. So this is one person, this is a CNN story. So CNN tweets something out, 100 people retweet it. Down on the bottom, you see this, I think this was an obit in the New York Times. And this thing kind of is going viral. And this is the sort of thing that you think of when you think of viral spreading. What's interesting about these figures is they all have roughly the same size. So each of them corresponds to about the same number of total adoptions, but they have gotten to the same level of popularity in very, very different ways. And we see almost every kind of intermediate combination as well, from a pure broadcast to purely viral, to things that are like a little bit broadcasty, to things that are mostly viral but still have broadcasts in them. And the most interesting sort of descriptive finding that we have is this finding of just incredible diversity, even conditioning on size. So what have we learned from this in terms of this sort of theoretical literature? Well, the first thing is that we may be looking in the wrong part of the parameter space, that a lot of studies of contagion have focused on what people call the tipping point, or in epidemiology, the epidemic threshold, the point at which things go from not spreading to spreading. and this is sort of where all the interesting stuff is supposed to happen, we find that everything we see is below the epidemic threshold, right? That most of the adoptions that we observe, the vast majority of them happen very close to the seed. And even these very large events that we look at are also consistent with a model, a theoretical model that is roughly speaking, subcritical. It's just dying out constantly, and then it hits some big hub and gets a burst of new life. And so we actually can visualize this in a tool that we built. And it turns out that Justin Bieber, unfortunately, plays an important role in the spread of information. He now has 45 million followers. I just checked this yesterday. And pretty much has 100% penetration. Wait, that's the wrong word. He has 100% of the American teenage girls following him. So he really is sort of able to sort of saturate an entire market. So when you have sort of effectively media channels like this operate, I mean, this is sort of larger than a network TV show. You're not really dealing with people anymore. You're not dealing with word of, even though Justin Bieber is a person, the way he is behaving in this ecosystem is more like a media channel. So this suggests both new directions for modeling as well as for marketing practice. But and it's also, I think, an example of where really having an enormous amount of data actually is scientifically useful, because when you're studying rare events, you need to have an enormous number of observations. Okay, but as exciting as that is, there are a couple of really important limitations to observational data. The first is that it's still very difficult to infer causality. We can predict things till we go blue in the face, but we still ultimately don't really know why things are happening. And the second, which is a little bit less obvious, is that you're not necessarily answering the question that you're interested in, right? So this is sort of a subtle point that social scientists get very grumpy about, which is that if you look at all this data that's been generated by products and services, these were not designed with social science questions in mind. So the position that you're often in as a scientist is that I have this dump of data that landed on my lap, and I have to figure out, to what question is this data the answer? And you can do sort of interesting and creative things like that, in that framework, but sometimes you actually want to start with the question, right? And so, and certainly you can't necessarily solve these problems just by getting more data, and so you have to have a new approach, which is where the experiments come in. So now you you start with your experimental design, you have your substantive question, you go out, you design your data collection strategy, and now you have some confidence that you're getting the data that addresses the thing that you're interested in. And of course, by experimental manipulation and randomized assignment, you can also help yourself to get a better handle on causality. So just to give you some sort of historical examples here, I started doing this kind of work about 10 years ago now, and our first paper that we published doing an experiment online was really sort of more of a field experiment, was replicating a famous 1960 study by Stanley Milgram called the Small World Experiment. And so he famously gave letters to people around the country to try to reach a person in Boston. You had to send it to a friend who sent it to a friend who sent it to a friend who finally reached the target person. And the famous result from this was that of the letters that reached the target, the length was about 6. So this is where this phrase 6 degrees of separation comes from. So we replicated this study about 40 years later on a much larger scale with many targets around the world. We had about 60,000 participants in 166 countries, and the figure on the right-hand side shows you how these chains, starting in the top left-hand corner and then going down the left column and then down the right column, several thousand chains converged on this one red dot here in Ithaca, New York, which is my old graduate school advisor, Steve Strogatz, who insisted on being part of this experiment. And so really the remarkable result from this experiment, well, there were two, I think. One is that when you correct for all the chains that fail along the way, the result is almost exactly the same as Milgram found back in the 1960s. So we have this sort of perception that the world has gotten smaller since then. In fact, in this particular sense, it doesn't seem to have changed at all, which actually is consistent with the theory. The second is that we discovered, sort of several years before Mechanical Turk came along, what we call the bored at work network. So this is millions of people sitting around at work at a desk with a computer in front of them, and if you can think of something that's slightly more entertaining than what they're currently doing, and remember that's sort of a low threshold, you can get them to do social science for you. In this case, we got 60,000 people to do an experiment for us for essentially zero money. So we thought, this is great, what else can we do? So we got interested in this other problem of how do we explain hits in cultural markets. Why did Harry Potter sell 350 million copies when J.K. Rowling's next book, which was published under a different name, Robert Galbraith, sold about 350 copies before everyone found out that it was J.K. Rowling? So we have this sort of folk intuition that things succeed because they're good, and yet the evidence is that even though successes are wildly more successful than average in cultural markets, even experts with a lot of skin in the game have trouble predicting them. So we actually conducted an experiment where we got 14,000 participants to choose between a bunch of songs that they hadn't heard of, and then we randomly assigned them to two different conditions. One, where they had to make decisions independently, and another where they were also given information about how many times the songs had been downloaded by other people. And so we were able to manipulate this, what we call the social information condition, and we were able to show through this experimental design that when people know what other people like, popular things become more popular, unpopular things become less popular, so inequality increases, but at the same time it becomes more difficult to predict which particular song is going to win. So the sort of more generalized result from this has to do with this notion of markets revealing preferences. This is something that economists talk about, that people have preferences, and markets, by presenting them with options, reveal what those preferences are. We showed that, this experiment shows that markets, in addition to revealing preferences, also construct them along the way, and this leads to a sort of inextricable kind of randomness in the result. So I will just skip the next example because I think I'm running short of time. This is just an experiment in which we tried to study the dynamics of networks in the context of a cooperation game, and found that allowing people to make and break ties with their playing partners dramatically increases the amount of cooperation that we see in a network. So I now want to just talk very quickly about some challenges. There's been a lot of excitement. There's been thousands of papers written in this new field of what we think of as computational social science. We have new conferences. We have new research centers. We have whole new journals. We have the field of computational social science. We have network science, which is related. We have big data, which I'm not really sure what that means, but it's generating a lot of excitement. And against this, I just want to remind you that we still haven't solved any of the problems that social scientists care about, and that many of us as citizens care about. We still have none of this has really made any contribution to the understanding of systemic risk in financial systems, which, 5 years after the collapse of Lehman Brothers, is still an enormous problem that is very poorly understood. We have very little ability to think about or control the dynamics of emerging epidemics. We don't understand the factors that affect cultural change, as Liz was sort of getting to at the end of her talk, understanding how to design for organizational performance. This is something that we've been talking about for 100 years now, and there's very little that we know about it. The same is true for predicting or ameliorating political conflict. So the big problems of social science are frustratingly elusive, and even like simpler questions like why do people when do people change their minds and why? Seems like we should know the answer to this question, but it turns out we do not know the answer to this question. So how do we sort of close the gap between all of this excitement and energy and the things that we care most about as social scientists? And there are a few things we can do, I think, to help. One is that a lot of the data that we are collecting these days is effectively siloed. That because of the nature of how it's collected, Facebook collects social interaction data, Google and Bing collect search queries, Amazon and eBay have e-commerce activity, Nielsen does ratings, we have email providers. None of these data sets are able to talk to each other because of the way that they are constructed and organized. And so, and yet many of the questions that as a social scientist you want to answer involve essentially joining these different modes of behavior at the individual level. So even if you just want to answer a simple question, who influences whom, you have to know something about the individuals and what they're like and what their predispositions are. You have to know who they're interacting with. You have to know what their behavior is. And you have to know what they're thinking they're doing. Okay, so these are all different types of data that are collected in different ways. And you really need to bring all of them to bear on the same question. So this sort of crazy idea that I have is what I call the social supercollider, which has the same acronym as the superconducting supercollider. And may turn out to be about as realistic. But it's this idea that we want to be able to bring all of these data sets together in a way that facilitates research. And we can sort of start with all the challenges, of which there are many. But I think it's an idea whose time has maybe come, at least to entertain. The second goes back to a very old challenge that the sociologist Morris Zeldich laid out in 1969. He said, can we put an army in a lab? Can we do macro sociological experiments with hundreds or thousands of people in a single organization and then have many, many observations of organizations of that scale? This was clearly impossible at the time. It's starting to be possible now, right? It's still not quite possible. If we look at Mechanical Turk, our best estimates are that at any given point in time, the largest number of people you have available to you is a few thousand, and they turn over very rapidly. But imagine if we could scale that up to 100,000 or 1 million and we could keep them around for a few years. This would fundamentally change the kinds of questions that we can ask, not just in terms of scale, but also in terms of duration, and in terms of making associations within individuals. So we could start to learn how individuals who play one sort of game in one way play another sort of game. And finally, I just want to, in the context of sort of interdisciplinary discussions here, point out that in social science, or in computational social science, it's very, very easy to appreciate the computational challenges. It's much more difficult to appreciate the challenges of asking the right question. And yet, social scientists spend an enormous amount of time asking the right question. And when you bring social scientists and computer scientists together, there is often mutual incomprehension on exactly this point. The computer scientist says, I've got this data, what question should I ask? And the sociologist sort of scratches his or her head and said, well, it's complicated. And the computer scientist says, well, thanks very much, I'm just going to go off and publish this paper in a computer science journal. And the reason is that often the data that you get is not the answer to the right question. And when you have a question, it's not clear how you go and get the data to answer that. And so there is this sort of mismatch between questions and data that requires a lot of sort of sitting around and talking and arguing. And this can literally take months. And this can be very frustrating if you're used to publishing a paper every 3 months. So there are sort of big differences in languages, in cultures, and in publication norms between the different disciplines here that are surprisingly hard to reconcile. Another big challenge is that if we want to sort of build these sort of great tools that I'm talking about, we're going to need to coordinate research designs. We're going to need to have coordinated platforms and data collection strategies and documentation. And this is bad. Even social scientists are pretty bad at doing this within their own field. So I'll just conclude by saying if we want to make progress in these big problems, we don't just need scientific innovation, we need institutional innovation as well. So thank you very much.
Thanks. It was a very interesting talk. So I have a couple of questions. The first one is that you showed the graph of the Twitter retweets, basically. So you obviously know, and a lot of people in this room probably know, that social networks follow a scale-free or a power law type of property. So does the retweeting power law, if you were to compute the parameter for the power law, is the parameter the same for the underlying social network? And the second is for the kind of things that you're going for, how accurate do you need to capture the human behavior, right? I mean, there is the network that's underlying, but there's also individual models of human behavior. I mean, how good a model do you need to actually capture these sort of things?
So it depends. Is the answer. It's certainly true that the underlying follower graph of Twitter is very much a scale-free network, which is actually kind of rare to have something so clean as that. And that turns out to be very important because for exactly this reason that I mentioned, that essentially you have this tremendous competition for attention whenever you retweet something or tweet something. And so the probability that anyone is going to retweet it is always very, very small. And so that's why everything's always dying out all the time. And then the only sort of force that's large enough to kind of counteract that is the occasional hub, right? So the scale freeness is important. It doesn't mean that the exponent is the same, right? I mean, I don't think we even really look at exponents these days. The second question is, how detailed of a model do you need? It depends very much on what it is that you're trying to explain. So we can account for a lot of the diversity, although not all, that we see in terms of structural diversity of popular events with an extraordinarily simple model, with really just sort of two parameters. And so there's nothing in there about the diversity of taste or how similar measures of similarity. I think that if you would probably be able to do a much better job if you accounted for some of that. And if you're in the business of marketing and trying to actually actively seed a network with information that you hope other people will spread, then you probably are going to want to build a very, very detailed model that has lots of information in about, what I can measure about people's interests. And, if you use Twitter at all, and I don't use it so much, but it's very clear to me, just in my own anecdotal experience, that, I'm followed by a bunch of people who are sort of interested in network science and computational social science. And so when I tweet about those things, they're interested. And if I try to tweet about something else, they're not interested. Okay? So I do think that this is a point that people often bring up, that there is some relationship between the nature of, there's a match between the nature of the content and the sort of identity of the person that is predictive. But I think, and if you wanted to sort of do this for real, then you would care about all of those things. So the answer is it depends on your application. Yeah.
Fantastic presentation. I can confirm that I'm a material scientist, but I work with sociologists, and it can be a nightmare. So
feeling is mutual.
Thanks. So the question I have, this particular sociologist, and I'm based at Stony Brook, he published this. It was a discovery that the famous people, this 5 seconds of fame, is actually not true, because most of the people who are already in spotlight, they're getting more and more fame, and people who are not, they're So did you try to do this experiment where you tried to spread the information several times, and just to see whether it follows the same patterns, or whether the new patterns develop, or every time you get the source and it goes through this particular nodes, and or whether it's something new developing every time you spread the information?
It's extremely varied. So because we looked at, when we did this sort of study of popular things, everything by definition had been introduced at least 100 times. So we have sort of 100, roughly speaking, 100 or more observations on the same piece of content, right? So you're controlling for everything here, right? It's not sort of similar pieces of content. It's exactly the same news story or exactly the same video. and it just being introduced by different people. And you see incredible variance, right? So most of the time, nothing happens. Some of the time, it spreads and spreads and spreads. And so then you think, oh, that's because some people are influencers. And, if I just start my stuff with them, then it will always spread. So then you look at the same person and all the things that they've introduced, and you see exactly the same pattern. Most of the time, it doesn't spread. And occasionally, they get something that spreads, right? Sometimes they're early on in the process. Sometimes they're later in the process. It's not to say that you couldn't sort of put together a model that says, well, it's the interaction between the content and the person and the point in time at which they participate in the cascade that tells you the answer. But I think, at that point, you're still sort of getting an R squared sort of somewhere in, between 0.2 and 0.3, right? So there's always going to be a lot of unexplained variance that just is sort of intrinsic to the process. So we know this happens. We see it in the in the music lab experiments. We've generated the same thing under experimental conditions. We see it all the time in observational data. I think there are just limits to what we can predict and limits to what we can manipulate, which is actually, I think, probably a good thing. Tony.
Great talk, Duncan. I'm sure you get this question all the time. Have you looked at phenomena where you don't perfectly retweet the content, but it's mutating, so the contagion is still happening, but the virus isn't a carbon copy of the initial one. So somebody sends me a photo of their cat or something, and then I send people I know a photo of my pet, and then everyone just starts saying, oh, look at how cute my pet is or something. And so the content isn't exactly the same. It's kind of evolving, but there's still some component of the message that's still coming across.
So we have not done that because we are looking at URLs. So everything has got a unique tag associated with it, and so there is exact copying happening. But Yuri Leskovets at Stanford has done some very nice work on what he calls meme tracker, where he has this sort of method which is borrowed from genomics, computational genomics, for associating all of the different kind of errors and mutations that happen when a natural language piece of content starts to spread, and sort of tracking them all back to the original root node. And then he can sort of track these aggregated memes over long periods of time. And Lada Adamic at Facebook has done the same thing for visual memes. So the most prominent recent example is the marriage equality meme that began as an equal sign I'm sure you all saw this as sort of a light-colored equal sign on a red background, and then people started reposting this as a statement of solidarity with the cause, and then people started making not ironic, but just sort of variations on. So some people had like 2 slices of bacon, and there were all kinds of like bunny rabbits, and there were many variations of this sort of basic meme, but that you're just supposed to get the reference to, right? So in some sense, these are clearly all part of the same thing. But I think this actually brings up a deeper question about social movements, right? Which is that we have this sort of intuitive notion of a social movement as a kind of monolithic thing, that everybody suddenly sort of wants to become part of this movement. My hypothesis, and this is just purely a guess, is that movements that succeed do so actually by capturing diversity. That you sort of have. So I'm looking at this with a postdoc right now in the Gezi Square, Occupy Gezi movement. And at first you see people talking about Occupy Gezi, but then you see all these other kinds of agendas get sort of co-opted or otherwise kind of glom onto this thing it's like once the bandwagon starts rolling, then other people say, okay, let's get on that one, right? And so it's sort of this interesting question about what's the relationship between diversity and success in terms of a social movement. And this is not something that is if you look at the theoretical literature, it all assumes that it's all the same thing. And in fact, it may precisely be because it's not all the same thing that it's becoming big, right? So, Wikipedia is another great example. Early on when it was Newpedia, Jimmy Wales said, in order to contribute to this thing, you have to be an expert and you have this sort of a minimum level of contribution that's required. And nobody participated. And then they said, okay, this is not working. Let's try something else crazy, which is let anybody contribute and let them contribute anything they want. And so what this had the effect of doing is sort of capturing the long tail, right? That some people are going to want to do a lot. Other people are going to want to do a little bit. Some people are going to want to edit. Other people are going to want to make corrections. Other people are going to want to contribute original content. Whatever. All of these things are now acceptable. And because you're sort of now capturing a much, much larger population, you're allowing for more diversity, you can sort of help yourself, which doesn't necessarily explain why Wikipedia, of all things, succeeded, but I do think that this is sort of almost a necessary condition for success.
Great. Well, let's thank Duncan and all of our speakers. And now our social movement heads to lunch.
Wait, before you leave, I have a few announcements. Could I?